Hi, Assalamualaikum warahmatullahi wabarakatuh. Today, we are going to present about our topic, Radio Frequency Interference, RFI. This is our group members. Aiman Syakirin bin Ahmad Sukri, Muhammad Dani Haikal bin Muhammad Kamal, Muhammad Fahid bin Muhammad Fakri, Mustaqim Fidyah bin Ibrahim, Muhammad Syahin Razanuddin bin Suhaimi. So, what is radio frequency interference? Radio frequency interference, RFI, is a specific type of electromagnetic pollution. It occurs when stray radio frequency signals disrupt, degrade, or completely block the normal operation of electronic devices and wireless communication systems. More generally, RFI is unwanted electromagnetic signals that disrupt the operation of electronic systems, especially where precise communication, navigation, and surveillance are needed.
Now, on to how radio frequency interference work. To know this, we must first break down the three main components: the source, the travel path, and the victim. Now, we go through the source. Radio frequency interference originates from various human-made sources. Both intentional and unintentional common sources include communication and navigation systems such as cellular networks, Wi-Fi satellites, radar, and broadcast transmitter, which can significantly affect sensitive systems like radio telescope and aviation equipment. Electronic devices, including industrial machinery and household appliances, may also emit unwanted radio frequency noise. In some cases, RFI is intentionally created through jamming, where signals are transmitted to disrupt normal communication. Next, we go through the travel path. Once electromagnetic energy leaves the source, it must travel through a path also known as coupling path to reach the vulnerable system. This transfer occurs through two primary propagation styles. The first style is called radiated coupling. This occurs when the source unintentionally functions as an antenna, radiating electromagnetic wave directly into free space. This path is highly dominant when the physical distance between the source and the victim is greater than one wavelength of the interfering signal's frequency. Next style is the conductor coupling. This happens when the unwanted RF energy travels along a direct physical electrical pathway linking the source and the victim. It typically hitches a ride using a shared power supply, lines, input or output cabling, or a common grounding network. Now on to the last component, which is the victim, or in this case, the receptor. It is the electronic component, antenna or circuit whose performance is degraded or whose function is entirely halted by the incoming interference. The underlying technical disruption happens through two core physical interactions. The first interaction is called front door coupling. This happens when the unwanted RF wave physically strikes the victim's dedicated reception ports, such as an antenna or receiver front end. This overloads the system, causing signal distortion, third intermodulation, or receive desensitization. And next is the backdoor coupling. The electromagnetic wave bypasses front-end filters entirely, directly penetrating the device's internal structure, SIM, circuit boards, trace, or power lines. When this wave intersect the wires, they induce a stray voltage and parasitic currents according to Faraday's law of induction. If this magnitude or this induced voltage exceeds...
Solutions for issues regarding radio frequency interference, RFI. Several techniques are used to reduce or eliminate radio frequency interference, RFI, especially in communication systems, radio astronomy, and electronic devices. The first one, shielding. Shielding is one of the most effective methods for preventing RFI. It involves enclosing electronic components or cables in conductive materials such as metal foil, braided metal mesh, or metal enclosures. This creates a Faraday cage which blocks external electromagnetic signals from entering and prevents internal signals from leaking out. For example, many communication cables are wrapped in metallic shielding to protect them from surrounding RF noise. The second one, filtering. Filters are used to remove unwanted frequencies while allowing the desired signals to pass through. A common example is the ferrite bit, the small cylindrical component often found on laptop charging cables and other electronic cords. Ferrite bits suppress high-frequency noise by absorbing and dissipating unwanted electromagnetic energy, reducing the interference that could affect nearby devices. The third one is regulation and standards. Government agencies and regulatory bodies help control RFI by enforcing electromagnetic compatibility standards. For example, the Federal Communications Commission (FCC) in the United States require manufacturers to test electronic products before they are marketed. These tests ensure that devices do not emit excessive radio frequency noise and can operate without causing harmful interference to other equipment. Similar regulations are enforced by authorities worldwide to maintain a reliable radio spectrum environment.
So next, I'm going to continue how radio frequency interference applicable in daily life. First, let's look at mobile phones. Have you ever placed your phone near a speaker and heard a buzzing or clicking sound before receiving a call or message? This is a common example of radio frequency interference. It happens because the radio signals transmitted by the mobile phones interfere with the electronic circuits inside the speaker, producing unwanted noise. Next, let's look at Wi-Fi networks. The second example is Wi-Fi networks. Wi-Fi routers operate using radio frequencies mainly at 2.4 GHz and 5 GHz. However, other electronic devices such as microwave ovens, Bluetooth device, and cordless phones also use similar frequency range. As a result, this device can interfere with Wi-Fi signals, causing slower internet speeds, weaker signal strength, or unstable network connection. Next, there is television and radio broadcasting. Radio frequency interference can affect the quality of television and radio reception. For example, you may experience static noise, distorted audio, or poor picture quality. This occurs when nearby electronic devices emit radio frequency signals that interfere with broadcasting frequencies. Another important area is medical equipment. In hospitals, strong radio signals from mobile phones or other communication devices may interfere with sensitive medical instruments. Because of this risk, some hospital areas restrict the use of wireless devices to ensure that medical equipment functions accurately and safely. Finally, radio frequency interference is also important in airports and aircraft. Electronic devices can potentially interfere with aircraft communication and navigation systems. Although modern aircraft are designed to minimize these effects, passengers are still instructed to switch the device to airplane mode during flights. This helps reduce possible interference and ensure safer communication between the aircraft and air traffic control.
Next, I will discuss some future development in radio frequency interference or RFI. The first development is AI-based interference detection. Artificial intelligence and machine learning technologies can automatically detect and classify source of interference in real time. AI can also predict interference pattern and select the best communication channel. For example, it can switch Wi-Fi channel automatically when interference is detected. This technology is expected to play an important role in future 5G and 6G network. The second development is advanced shielding materials. Researchers are developing new materials that can block unwanted radio signal more effectively. These materials are lightweight, and flexible, making them suitable for use in smartphone and medical equipment, and also wearable device. The third development is cognitive radio technology. Cognitive radios that are intelligent systems that can sense their surrounding radio environment and automatically select unused frequencies. This helps reduce interference and improve the efficiency of wireless communication system. The fourth development is improved spectrum management. Better frequency management technique can reduce signal congestion and allow multiple users to share radio frequencies more efficiently. This is becoming increasingly important as the number of wireless devices continues to grow. Finally, interference-resistant communication systems are being developed. Future wireless technology, including 6G, are designed to handle interference more effectively, providing users with more stable and reliable connection. In conclusion, these emerging technologies have the potential to significantly reduce RFI problem and improve the performance of future communication systems.
For the last part, we have conclusion. In conclusion, radio frequency interference is unwanted electromagnetic signal that disrupt electronic devices and communication system. RFI come from various sources and affect our daily life through mobile phones, Wi-Fi, medical equipment, and aircraft system. We can reduce RFI through shielding, filtering, and following electromagnetic compatibility standards. With future technologies like AI detection and advanced shielding materials, we can better manage interference in 5G and 6G networks. Therefore, understanding RFI is crucial for maintaining reliable wireless communication in our modern world. That's all from us. Thank you.